Okay, welcome to the washer technique. So we're still going to revolve around the x-axis, but notice that my representative rectangle does not touch my axis of revolution. All right, so what's going to happen here is now we're going to have two radii to look for. We're going to have capital R of x, that's always going to be the longest radius, and we'll have lowercase r of x, that's my shorter radius. You still have the thickness of your reference or representative rectangle. But as I revolve this around the x-axis, here's my capital R of x to the top of that disk. And then here's little r of x, which is the empty disk, which actually makes it a disk with a hole in it. That's my washer. So to find my volume, we are going to take the radius, capital R of x, square it times pi dx. We're going to find the volume of our inner disk that we're subtracting away. We'll combine these two together. We'll factor out the pi. We'll factor out the change in x. And then here's my formula for my inside function. So my washer method will be to integrate from a to b. We'll keep the pi out in front because that's just a scalar factor. Take the rate capital R of x function, square it, minus the little r of x function, square it, and we'll integrate it with respect to dx. So here's an example. Find the volume of a solid formed by revolving the region bounded by y equals x and y equals 4x minus x squared about the x-axis. Okay, they didn't tell me the bounds, so therefore I have to go set this x expression equal to this one to find out where the two are going to intersect. So x equals 4x minus x squared, so I want a positive x squared, so I'm going to add that over to the left. I'll subtract over the 4x. Gives me x squared minus 3x equals 0, which means we can factor out an x as the GCF, set both of these factors equal to 0 and x equals 0, and then x equals 3. Substitute these x's back into this equation for x, and you'll have the point 0, 0, and 3, 3. Those are my two intersection points, so I plot them. And we'll graph our line. That's the y equals x line right there. Put that one in red. Here's 4 minus x squared, that's in blue. And then we'll graph the x-axis, that's in green. So again, if you wanted to, what I would recommend, go to your calculator, enter your 4 minus x squared, and now that you know that the x's you want are from 0 to 3, hit second table, find your points 0, 0, 1, 3, 2, 4, 3, 3. Plot those points on your graph so you make a really good looking parabola. And if you want 1, 2, 3, 4, there's 4, 0, plotting another point right there. I would always encourage using your calculator to find the exact points you're looking for. So again, we're rotating this around the x-axis. We have to be perpendicular with our reference rectangle. There it is. There's my change in x. All right, so we're going to need our washer technique because we're missing this space. So my capital R of x is from the top of my rectangle, which is the blue curve. All right, so there's the 4 minus x squared, all that being squared. Little r of x is the part that's missing to the axis of revolution. So that's going to be just the x. That's this equation. They're squared. We'll have to FOIL this out. So foiling is going to give me 16x squared. We'll have minus 4x cubed and another minus 4x cubed, which is minus 8x cubed. Minus x squared times minus x squared will give me a positive 4x. Positive 4x to the fourth. And then minus the x being squared right there. We combine like terms. I personally like to put these in descending order of my powers before I integrate them. So we're going to have x to the fifth over 5 minus 8x to the fourth over 4. We'll reduce the 8 and a 4. Plus 15x cubed over 3. We'll reduce the 15 into 3 to get these values here. We are integrating from 0 to 3 as we found those values here. Again, the nice thing about When you substitute in the lower bound of 0, all these terms will zero out. So our answer is basically going to be just plugging in the 3. So substitute that in. You can leave this as 3 to the 5th minus 2, 3 to the 4th, plus 5 times 3 to the 3rd, and then let the calculator crunch the numbers, or if you want to calculate each number out. But again, I'm a big component of letting the calculator do all that small itty-bitty work. So 243 over 5, you could go minus 162 plus 135. If you want to do that in your head, that's fine. Make sure your calculator checks everything. So 108 over 5, then multiply it by the pi, and that's my units cubed. All right? And again, real quick, remember I showed you this before. Just want to remind you. All right, how can I grade this problem? Again, remember in the home screen. All right, underneath math, you can do your integral right here, number 9. So I would leave the pi symbol out. We'll enter 0 to 3. So 0, right arrow 3, right arrow. Now we got to go inside the parentheses. So these parentheses that you see in the calculator are acting like the brackets right there. So we need to type in another left parentheses, 4x minus x squared, close those parentheses and square it, and then minus, and we can do this x squared right here between our ears, so then minus an x squared. And then we have to say what variable are we integrating by? We're integrating with respect to x. All right, and we'll hit enter. Now, we want a fractional answer. It might come up as a decimal, so if you want the fraction, attached to the math, number 1 will return your answer as a fraction. If you don't put that there, just to show you, it'll probably give you a decimal answer, 21.6. And so if you get this decimal answer and you want it to be a fraction, then hit math, enter. It'll take that previous decimal and turn it into a fraction for you. And then you put your pi on it, and you have your answer in terms of pi. If they want a decimal answer and they tell you to use 3.14, plug it in, and we'll create a decimal. All right, what you don't want to do is if they want a decimal answer and they say pi is 3.14, don't put the pi symbol in front of the integral. Just to let you know, second pi in this calculator goes out to a bunch of decimal places. That will increase your rounding error. All right, next, we have used our previous example, but now we're going to change our axis of revolution to y equals -1 down here. So what's that going to do is it's going to lengthen your r of x, and it's going to lengthen your little r of x. So 4x minus x squared, that's the top function, minus this axis of revolution, minus a -1, changes that to a +1. The little r of x, which was x, minus the -1, becomes now +1. So we'll put that into our integral, multiply this all out. So over here to the left, I did multiplying, writing it out twice. A negative x squared times negative x squared is x to the 4th, negative x squared times 4x, negative 4x to the 3rd, negative x squared times 1, negative x squared. Then multiply the 4x to each term, negative 4x cubed plus 16x squared plus 4x. Multiplying by 1, just copy this and line them up under your like terms. Vertically combine your like terms, and that takes care of that trinomial squared. Minus binomial squared, x times x, x squared, x times 1 is 1x, double it to 2x, 1 times 1 is 1. Distribute the minus sign, minus x squared with the 14x squared makes this 13x squared. Distribute the minus to the 2x, 8x minus 2x is 6x. Distribute to this +1 is now -1. These ones cancel out. We integrate. We get x to the fifth minus 2x to the fourth plus 13x cubed over 3 plus 3x squared. Again, putting 0 in as the lower bound is just going to zero out. So substituting in the 3 will give you your answer. And again, like I said in the previous problem, you can just set, all I need to do is see 3 to the fifth over x minus 2 times 3 to the fourth plus 13 times 3 to the third over 3 plus 3 times 3 squared. Let the calculator do the work. We get 153 over 5. Multiply the pi to it. That's your units cubed. And that's our washer technique.